Hi guys, very good morning and welcome back to our YouTube channel. So today we have came with another questions that we are generally doing. So let's get started. Yeah, so today's questions is minimum time to repair the cars. So let's first try to understand the questions, the problem statements we will understand, and then we will jump on the algo, and post that we will jump on the code and TC and SC, that is time and space complexity analysis. Cool. So let's first understand the question. So what is given to us? You are given an integer array ranks representing the ranks of some mechanics. So initially they have given a ranks array to us, which is representing the ranks of some mechanics, and rank I is the rank of the ith mechanic. So on a particular garage, let's suppose there are some highly proficient mechanics are there, so he should be placed at a rank 1 for sure. And let's suppose there is a new joinee on the garage, then he should be placed on a rank of 4, like this way. Like more lesser rank, the better of the performance of that mechanics. And how I am stating that? So just by the very next lines, a mechanic with rank R can repair n cars in R into n square minute. So if a particular mechanics are repairing n cars, and if his rank is R, then he can repair the cars, repair the all n cars in R cross n square minutes. Now let's suppose two mechanics, one with rank 4 and another with rank 1, one with rank 4, another with rank 1. Now let's suppose we are giving two cars to repair them, so n is going to be 2, so 2 square is 4. So this factor, like this n square factor, is constant for both the mechanics. How then which mechanics is going to be take lesser time? Which mechanics is going to be take lesser time? The mechanics whose rank is lesser, the mechanics whose rank is lesser. So a mechanic with rank 1 can repair the two cars with n is 2 and n square is 4, so 4 into 1 is 4 minutes. And the same time, and the same like same effort with two cars need to be repaired. A mechanic who is just a new joinee of the particular garage is going to be take a n square is, for our case, is 4 and his rank is 4, so 4 into 4, that is 16 minutes. A rank 1 mechanics can repair the cars, two cars, with 4 minutes, and rank 4 mechanics can do the same job in 16 minutes. 16 minutes. So who is efficient, who is fast, who is more, I have to say, is more skillful on this particular garage? Whose rank is lesser? Whose rank is lesser? So like this way, I think you got the exact gist of the question. And like this way, there is another things, a cars factor, which is we are bound to expect to this particular questions. So you are also given an integer cars representing the total number of cars waiting in the garage to be repaired. So we have total cars number of cars in the particular garage to be repaired. Now what we have to return the minimum time taken to repair all the cars, like repair all the total cars present in the particular garage. Now note, all the mechanics can repair the cars simultaneously, so that means there are parallel processing they can do. So that means when rank 4 mechanics is repairing some cars, rank 2 mechanics also doing to repair some cars, and rank 3 mechanics also do to repair some cars. Like when a particular mechanics is doing his job, other mechanics can also do same time simultaneously. Other mechanics can pick some other cars and do the repairing of this particular cars. There we don't have to wait, like when a particular mechanics is doing a particular car repairing, other mechanics have to wait for them to get his job to be finished. No, that is not the case. They can parallel processing, they can do parallel processing. So that is the very basic standard practice. When you are going to be on the garage, the same things are usually happens. Now if you are following us like on last 3 to 4 days, so the I am pretty confident. If you are following like the entire like the series of last 2 to 3 days at least, where we are solving the questions of the pattern of binary search on answer, the patterns on binary search on answer, then these questions, I guess, mostly my hunch is you are able to solve by your own. You are able to solve. So today I am not going to get the brute force or any other solution. I am directly giving you the binary search approach, how binary search on answer is going to be help on this particular question solutions. So I am pretty sure like that is very basic. So compared to like yesterday, or I think day before yesterday's one is like k allocations, that is on the medium path. But before that day, where I think there is some making some arrays to be a zero array, something like this. So that questions I have to say is more than medium level questions, and yesterday's question is also a more than a medium level questions. So, and to identifying it is a binary search on answer is completely a bit challenging altogether. So if you are following that videos, and if you after following that videos you are on this video, so I am pretty confident you are able to solve this question by your own only. So there is no like super magic we are doing. We are straightforwarding doing binary search on answer and a little bit maths altogether. So yeah, now let's jump on one note as we are usually do. So I am just giving you what is your answer boundary altogether. What is your answer line boundary altogether. I am giving you that gist only and is possible function. And we all know our standard template. For yesterday's question, there is a little trick. So as per the questions, we have to change our template, but mostly 90 to 95% questions is solvable by the template I am giving to you guys for binary search. By 95% question can be solvable by the template we are following. So today's question is also one of them, which is just the template you have to follow. Just the template you have to follow. Cool. So again, like I am not giving you how you are going to come with a monotonous sequence. There is a monotonous answer boundary can be happen. So by solving that much question, that difficulty of questions that we faced on last couple of days, so you should be able. But yeah, let's just quickly discuss. So our answer, so that is our answer boundary. What it is? That is our answer boundary. So our answer boundary. What is, can you pinpoint me what is the minimum answer can be possible? What is the minimum answer can be possible? What is the minimum answer can be possible? So can I say, like, if let's suppose I have cars equals to that many cars, and let's suppose I have total n mechanics to my house, to my garage, actually n mechanics to my house, to my garage, and if I have number of cars to my garage, and if I am equally distributing, the cars to all the mechanics, and if I am equal, let's suppose all the mechanics have same efficiency. How we are defining the efficiency? By the rank. Let's suppose all are of rank 1, so you have to think some kind of hypothetical scenarios to pinpoint your mean and max boundary, so you have to think some identity elements, to pinpoint your mean and max boundary. So what's the assumptions? So that is every question specific, that I can give you, like, hey man, that is your identity elements and that is going to be constant for every question. No. So that actually the problem solving ability, that actually the thinking ability that you have to build by solving numerous questions. You have to make your brain on the search go, like after solving, let's suppose n number of questions, you are able to think of n plus 1 number of questions. That is by problem solving. And I can giving you a template, a standard template on binary search on answer, or let's suppose DFS, that I can obviously give you. But what is your identity elements for this particular, that you have to build by your own, by solving more number of questions, So for this case, we have the identity elements. Let's suppose our ranks array has everyone having same efficiency. So everyone is of rank 1 or rank 2, rank 3, anything. So that is everyone is same on garage. Is our identity of determine our left and right. As simple as that. Now if everyone has same efficiency, then I can apply my greedy approach to distribute the cars to everyone, equal number of cars to everyone. So what is then each mechanics then can get a car of, if there are total of cars car in the garage, and if I have total n mechanics in the garage, then I can say that is of math.sil of. So sil, why I am taking, that is very intuitive. I think everyone is every one of you guys getting why I am taking maths of sil of cars by n. So that is the reasons. Let's suppose we have total of 3 cars, and let's suppose we are, so that is not going to be an integer division. So on that case, there are some fractional cars. So if there are some fractional cars, we are considering a new mechanics is altogether going to get the another highest numbers, another like sil value of this particular numbers of cars is altogether. So that's the reasons I am putting like math of sil of cars of n. That is class 8 or 9 standard maths. Why I am taking each mechanics. If you have like cars, number of cars in the garage, and if you have n mechanics, so what is the each mechanics, how many cars is going to be we are distributing. So that is of math of sil of cars by n. That is of class 8 or 9 standard. Why I am not taking maths of load, why I took maths of sil, that is of class 8 standard. Because the main reason is I am not going to, I am getting you, I am giving them what is the maximum boundary. If there are some fractional divisions, after fractional divisions, if I have to permit more cars to a if I am left with some fractional cards to allow to a particular mechanics, no, I am not doing so. I am giving what is the upper boundary of cards. So like this way we are able to assign all the cards to all the mechanics. Otherwise, if we will carry the fraction, so there can be cases we are exhausted of mechanics and there are few cards after adding the fraction. So we can't divide our cards into fractions. We have to take the seal value of them. So that is the each mechanics can get that many cards. Correct? And as we already took the assumption that each of the mechanics have identity ranking, all the mechanics are going to be take of equal time to basically, what can I say, like repair the cards. So what is the max time on this case? Max time is each is going to assign with a card of each, and if everyone is of identity, then can I say like what is, like, let's suppose ranks of 0. So each is basically that is of square, because n square, you remember the formula, that is of r into n square, that is the time. So our time formula is r into what it is, r into n square. So that max time can be each into nums of 0 if everyone is of same. What is our mean time? Then on that case, each into ranks of 0 again. There is no change. Now just a little tweak. If mechanics have different efficiency, then what is the formula? That is just change nums of 0 to max of, here I am taking max, right? Okay, so max of ranks. And if everyone has different efficiency, what's the formula? Mean of ranks. That is for sure. So I think you guys are easily get these formulas. Like we are distributing the cards to every mechanics, how it is, that is of this each mechanics, how we got these cards divided by n square, cards divided by n, we got each mechanics will get this much cards. And what is our max time? It is of each square into what is the maximum rank. So that mechanics is going to take the entire maximum time, because we are doing parallel processing, and if one mechanics is going to be take 16 minutes, and other mechanics are able to like wrap their jobs to like 9 minutes, 10 minutes, like this way, within 10 minutes other mechanics are able to wrap their jobs. So no matter what, you have to open your garage at like what is the maximum time a particular mechanics is taking. You have to open your garage till that time. So what is it? So it is of each square. So that is the number of cards that particular mechanics is got at, and square of that, because our formula is r into n square, into max of rank. What is the maximum rank this particular mechanics, a particular ranks array have? So that much time we have to make our garage open. And what is the minimum? That is just the same formula. Each square into mean of rank. So the very earliest mechanics, what is the earliest mechanics is able to wrap his job? So that is of each square into mean rank. So that is the minimum rank he is able to solve. And how I am pinpoint, that is our mean and max boundary, because every mechanics, let's suppose, have identical ranking. So your max is altogether going to be this, and your mean is altogether going to be this only. So on this case, if I have the boundary, then we have successfully able to pinpoint our mean and max, which is nothing but our left and right pointer, which is basically our left and right pointer. So we are able to fix our left and right pointer. Now if can you tell me, like, is there a monotonous sequence of validity and invalidity that we are solving last 3 to 4 days? If there is a point of validity and invalidity, yes, obviously. So let's suppose if I am standing at this particular point, and if I am standing with this particular time, that is a valid time. So can I say our entire right boundaries are valid? Can I say our entire right boundaries are valid? Yes, obviously I can say, because let's suppose I got some arrangement of the cards to give to a particular mechanics, and with this I am able to close my garage with this mid. What is our mid is going to be point, that is our mid, this particular time. So now if I want to open my garage of some more time, can I do so by making all the mechanics busy, by making at least one mechanics busy, by at least making one mechanics busy? Yes, I can do. I will assign the highest rank mechanics to some extra card. I can increase his card count. So then our garage opening time is going to be more, because one mechanics is at least busy, right? So right point 2 we are sorted. So if I on the particular mid, and if I am saying that if it is a valid window, then yes, the entire right portion is valid, but on the questions it is stated what is the minimum time taken to repair the all the cars, so that I can close my garage as quickly as possible, so I know right is valid. So what is the next goal? So hey right, can you move yourself to mid -1? So our right is going to be mid -1. So I know the for sure that our right portion is valid altogether. Now can you move yourself to mid -1 to check if I can make my garage to close some quicker time. So I have moved my right pointer to mid -1. Let's suppose if I am at this positions at this mid, then and it is a point of invalid, then okay, this by assigning this current arrangement, we are not able to close my garage with mid time. So I have to open my garage some more time. But what? That I will figure out by binary search. So on that case, my left pointer is going to be mid +1. My left pointer, which is standing over here, that is going to be just after this. So my left pointer is going to be a mid +1 index. That's for sure. Cool. So now go to the code and try to understand. I will come on the is possible functions after that. So I have make the equal distributions of cards to be math of ceil of cards by n, what we just explain on this video on the OneNote that we have, and then max time after equal distribution, what it is, that is of cards equal distribution into cards equal distribution, that is nothing but like cards equal distributions to the power 2, the same things, into max rank. And initially I have calculated what is the max rank present in the array and what is the min rank present in that. Is very straightforward. I have iterated over the ranks array and I have assigned max rank to be max rank of rank, max of max rank and rank, and I have assigned min rank to be min rank and rank. And similarly I have calculated the min time taken after each distributions, and now I am very good to set my left and right pointer to this particular. Left should be min time and right should be max time. Answer is -1, and I am doing my standard template that we are following from last 3 to 4 videos. Left, while left less than equals to our mid, I am pointing out to left plus right, right shift by 1, that is of if we are doing a binary search, if we are doing a bitwise right shift by 1, that is nothing but a divided by 2 1, and we are calling out is possible. And if it is a possible, then why not the right, you are shrink you to right to mid -1. I will search to close our garage to some smaller time, and if that is a point of invalidity, so I have to open my garage to some more time, and I am moving my left pointer to mid +1. I am moving my left pointer to mid +1, and now understand what we have written on the is possible functions altogether. So is possible functions is today's one is a very simple and very straightforward. So we have started with cars repair, how many cars we have able to repair so far, and we are iterating over the ranks array. And now we are trying to assign a particular individual to a boundary. We have a time allocation boundary, so that is of the max time. We are initially have the context, so we will close our garage to this much time and a particular mechanic. So let me just quickly go to the OneNote to give you a gist. So a particular mechanic have rank equals to rank, which we know, and I don't know. So that is known, that we know. But in square, what is the in square? How many card I am going to assign this particular mechanics, that we don't know. So that we don't know. And there is a max time we have defined by the binary search, that we also know. Now if I want to find n square, that is a class 8 to 9 standard or maybe 5 to 6 standard maths, which is how you can do so. So your n square is nothing but your max time divided by rank, that is for sure. And then n is nothing but some math dot square root of, or like this way I have to write max time divided by rank. As simple as that. So that is of our how many cars this particular individual having rank as rank, and max time he can spend of all the cars we have defined. So that is nothing but of math of square root of max time divided by rank. As simple as that. Right? So exactly same things I think I have written over here. So which is nothing but, so obviously we have to take the floor. So if a particular mechanics is able to, let's suppose is doing the things like some portions of the cars is he is basically left off, then we are not going to assign the entire car to him. So I am very greedy because I have the max time. So I am taking a integer divisions altogether. So I am giving max time divided by rank, that we have just saw on this video, just saw on the OneNote explanations, and I am doing the maths of square root. And after doing the maths of square root, let's suppose we have some fractions. What is the fractions? So let's suppose we are assigning, let's suppose 3.7 cards to this particular individuals. So now we not do math.sil. Now we not do math.sil, because otherwise if we are assigning he is able to repair 3.7 cards without max boundary. Without max boundary, he is able to repair 3.7 cards. Let's suppose without max boundary he is able to repair 3.7 cards. Now if I am greedy, and if I am telling you, hey man, why not 4 cars you are solving? So there is no fractions in our cars garage. So hey man, why not you are taking entire 4 cars to repair? Oh, if I have to take the entire 4 car, then this mechanics is going to violate our max time boundary for sure. So that's the reasons I'm not giving you the entire 4 car. So I am giving the 3 cars altogether, because I know he has the capability of repairing 3.7 cars within our max time frame. So he is very sure, I am very sure, by giving you 3 cars, he is able to repair the entire cars without max time frame. And now, so that is the cars repair variables we are updating. So this particular mechanics is able to repair this many cars, and I am updating to our cars repair till now how many cars we have able to repair this particular variables, and I have updated to this. And if at any particular time we are able to repair more than equals to cars number of cars that is given to us, that is more than equals to cars number of cars, then we can return a true. So that is a valid arrangement. We are able to repair that many cars with this max time as a boundary. And if this entire for loop executed and we are not able to repair the cars number of cars that is in our garage, then in that case we are returning false altogether. It is as simple as that. Cool. So that's the entire explanations for the today's question. There is no super magic. There is no, I don't have to say that is not a very medium level questions altogether for you guys. If you are following us till like last 2 to 3 days, so that is obviously an easy level question if you are following us from, because on last couple of days I remembered we are solved tremendous difficult level questions. To identify this is a binary search questions altogether is a challenge. So today's question is a cakewalk for all of us. Cool. So now quickly discuss the time complexity. I don't want to do the time complexity discussions today, because that is nothing on this time complexity discussions. What is the time complexity? But the sake of simplicity, let's quickly do this. So here I am iterating over the ranks array. So that is the for sure is going to be taking of big of in, and after that what I am doing here, I am doing a standard binary search on the boundary, so that I can write it in the terms of n or something. I am not going to go very trivial mathematical distributions to this. On if you are able to identify that is a binary search on answer question in interview perspective, I am stating then interview should be more than happy, and to if you are giving you an time complexity on non-mathematical term. So I will state which particular question you have to distribute your thought process to a more granular mathematical type, like SIF question you guys remembered. So that particular question interviewer looking how granular level explanation on TC you can give them. But for this question it is very trivial, and we are doing a standard n iterations on this is possible functions that we are for sure. So this n is for is possible functions, and here we are doing some kind of log n factor things only. Yeah, that is our entire time complexity for this particular question. And is something like, are we using any space altogether? No, right? All are variables. All are variables for today. So the space part we are very good. So we are using space of big of 1 altogether. Right. So that is all about on the today's question part. And if you guys understood till this point, please do subscribe to our channel, and please turn on the notifications when we are going to be live. And today's we have a bonus tips on resume roasting. I will try to put this video on today for you guys. So yeah, let's meet on this video all together, and tomorrow we will come with another banger question. So bye guys, bye for today, bye.